No, this is the main. Okay, yeah, okay. Just. Okay, hello. I am Maddie Hunt, and this is Jordan Gobel, and we did properties and operations of roots.
Let me check something.
Okay, we're checking. There you go.
Okay, the square root of a number a value that when multiplied by itself gives the same number. The cube root of the number is a special value that when used in multiplication 3 times, it gives you that number, and so on for fourth roots. Okay, so for prime factorization, this is like the first step in this process. And so what you want to do is for a number, to find the prime factor numbers, you have to find the lowest prime number in that, and then just keep going down. So the lowest prime number in 75 would be 3, and then for 25, the lowest one would be 5, and so then that equals 3 times 5 squared.
And roots, it's a number that must be multiplied times itself to give n times to an equal given value. So say you want to find a certain value like of cubes or fourth roots, so you do like 4 to the square root of a certain number. And we have a problem for you guys to do. What is n in this equation? The nth root of 625 equals 5.
So do it. What is it?
Do it.
Anyone?
Just won't say what the
Four.
answer is.
Yeah, well, I'm just seeing if anybody knows the answer.
Hey, good job. Good job.
What?
What?
One. It's 4.
You can't use your calculator. Take it.
N equals 4 because 5 to the 4th power equals 625. Adding and subtracting. Say that you have the problem a squared plus b squared equals c squared, which should sound familiar. To calculate for c, set the problem like c equals the square root of a squared plus b squared, and solve for c, which is not exactly the same as c equals a plus b.
Okay. For multiplication and division, you can pull apart the numbers. So for this one, like you just split the a and b and then make it into their own thing. And this can help you simplify the expression. So that is one example. That's a long example, but it also works for division too. So if you have like the square root of a over b, then you can split apart that and make it the nth root of a over the nth root of b. And then that's another example of that with numbers instead of letters.
And then we have our rational exponents. A rational exponent looks like this. It's basically the nth root, and it equals 1 over a to the nth power. An example of this would be 2 to the 1/2 equals square root of 2.
It's just different ways of writing it. And then that is all.